Okay, Bex. Is there anything? Yeah, a waterfall. Cool. But your image kind of blurry compared to the waterfall image. Okay, okay, Bex. Still haven't learned anything new yet? Huh? Yes? Still learning the same thing? Oh, 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 oh. Oh, okay, okay, okay. But did you learn any but did you learn anything from previous in your schools? Hmm? Did you learn any? Yes, what was it? The pattern for from what? Yeah, 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 yeah. Is it a number pattern or maybe a what is it? Uh oh, I think I know where will this going, the topic going. So okay, just share screen your screen. Just do your share screen. Okay, okay. Let's see, let's see. Uh-uh. Okay. Green mathematics. Okay. Discussions. Oh. No, okay, okay. Okay, okay, good. Why? Yes. Mm, yes. Yes, yes. Good. Okay, okay, okay. Good. Okay, okay. Okay. Whoa, whoa, whoa. There's a lot of pattern here. Mm-hmm. Yeah. Mm-hmm. Mm-hmm. It's good. Mm-hmm. Okay, okay, okay. Mm-hmm. Mm-hmm. Ah. Mm-hmm. Mm-hmm. Yes. Okay. Mm-hmm. Oh, oh, okay. Mm-hmm. Okay, okay, okay. Good, good, good. Okay. Let me let me share screenshot first the question. Okay. What was the question? The okay. Which one do you want to discuss? Which one did you think? Okay, okay, okay. I think this is kind of new. Okay. This one, the dot, the red dot one, the red dot questions. Okay. Yeah. Yes, pattern two. Okay. Okay. Let me screenshot the Q8. Complete the table below. Okay. And then we had the next one. What was it? Q9 and so on. Oh no, no, I haven't. I haven't. I only the. Oh, okay. Okay, okay. Let's discuss the Q. Let's discuss the red dot thing. Okay. Okay. Now let me share my screen now. Okay. You can turn off your screen. Okay. Okay. Good. Can you see my screen now? Okay. 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 So let's see. The task one, investigate the pattern below. Okay. Stage number one, you have zero, zero squares. Okay. In the second, you have one. In the third, you have two. Yeah, because this is obviously one, right? This is one. This is zero square. This is one square. This is one and two. This is one, two, three, right? One, two, three, four. Yeah. So if you have, for example, this is the first, I would say that this is the first pattern, right? This is the first pattern. This is the second. This is the third. This is the fourth. This is the five. So did you see the pattern here, Bex? So if I say if you have 10 in the 10 pattern, nine, good. So you just subtract it with one, right? So pattern minus one. Yeah, yeah, too easy. Yeah, so six will become five, right? And this will become six. Okay, so yeah. Okay, so if you have Q10, answer, yeah, answer Q10. What is the answer of the Q10? Write the general rule for the number of dots S in term of N. So N. So basically, yeah. Mm, okay, okay, okay. Okay, scroll, scroll. Okay, this one. Okay, let me erase this. I hope it doesn't bother you. Yeah, this is one dot. Yes. S equal to N minus 1. For the general rule for the number of dots. General number of dots, not the number of squares. Yeah, so the question the okay, let's see, yeah, let's see. Okay, so the general rule then, your answer, general rule for the dots, number of dots will be n times n, which is n squared. Have you ever heard about squared? Yeah, okay, n squared, right? Okay, so Okay, let's skip that. Okay, centimeter squared. Yeah, centimeter squared. Yeah, you can do that also, but you don't really have to do that. Yeah, because well, basically, to add a, oh, what is that called? The unit. Yeah, this is the unit, right? So you have to look up what the quantity. For example, the variable s. S represent what, Bex? S represent what? Dots. Okay, so I think it will be better if you denote it, if you use D instead of D. Use D instead of S. Well, yeah. Well, it's okay, but D equal to dots, right? Because D represent a dots. Oh, okay, okay. Oh, yeah, yeah, yeah. Number of dot S. Yeah, of course. Yeah. Oh, yeah, yeah. The question S for S. Okay, okay. I missed. I'm doing a mistake now. Yeah, because yeah, but for maybe if the questions doesn't give you any, what is it? Any descriptions of what the quantity is, yeah, you can use a more intuitive variable to describe your equations. Yeah. Yeah, because if the question doesn't give you S as the number of dots, maybe S will be interpreted if another person reading the equation, maybe they will be thinking that S represent the sides of the pattern or something. But yeah, but because the number of dot represent with a D, with a yes, with an S, so we'll just use S then. Okay. So again, you don't really have to. Well, in math, we doesn't really care about the units, so just not writing it, it's not a big problem also. Okay, so to verify, okay, to verify that your equation is true, you have to test it, right? So yeah, verify. Okay, so if I have S5, length equal 3, then the dot will be equal to, well, yeah, your Bayesian formula is equal to 9. Okay, now let's check. Is it right or not? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yay! 9. Yippee! Okay, if I have n equal to 4, it's supposed to be 16, right? So let's calculating it again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, good. Okay. Okay, 16. Okay then. Okay, okay. Good, good, good. I think this equations will hold forever. Yeah, I hope so. Yeah, because in mathematics itself, yeah. So let me tell you something about what is that called? Induction. Yeah. Have you heard about inductions in mathematics, Bex? Inductions? What was it, Bex? Yeah, what was it then, Bex? What is inductions in mathematics, Bex? No, 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 no. Of course not. So, inductions itself, yeah, it's one of the method of proving in mathematics. So, proving itself, well, well, of course, you know what proof is, right? So, if you want to convince to another mathematician that your equation is true, yeah, of course, you have to show it, yeah. Of course you have to show how can it be true. Yeah, one of those method is induction. So induction itself is that you you, what was it? Yeah, how would I describe it? You take sample of the problems. Yeah, you find pattern of a problem of the problem, and then you generalized it for all the problems. Yeah. So you just take a little as a sample to find a pattern from it, and then make a general equation to describe the whole problem. Yeah, because so can you identify what is the general problem for this specs? Yeah. Okay, maybe start from the the spatial problem. Yeah, from the little problem. What is the little problem that you were trying to solve in this case specs? Yeah. So okay, the big problem is that you want to, for example, you have a pattern of n, how many sides, how many dots it will have, right. So if you have arbitrary number of pattern n, yeah, how many will be the existing dots in the pattern? That's the general problem, right? That's the general problem. That's what we want to try to solve. Yeah, okay. Now we try to solve it by seeing the pattern in the second. Yeah, in this case, yeah, we see the for the first pattern, and then the second pattern, and the third pattern. Yeah, yeah, and then by now we see that, oh, okay, so we know that if we have, yeah, based on our observation, yeah, based on our observation, that we know that, oh, the number of pattern correspond to the number of dots, yeah, which is the number of pattern squared is the sum of the dots existing in the patterns, right? Yeah. Now we want to extend it, extend it to a much more general form by using this formula. So what we have done here is a method of induction. Yeah, mathematical induction. So by seeing for n equal to 3, n equal to 4, yeah, we can use it to generalize to solve the problem in general. Okay, so if you have, for example, a much more higher number of n, so for example n equal to 25, how many the dots will be? X 25 squared, then, right? 25 squared. Yeah. Really? 25 squared, not still not correct, Max. Still not correct. 25 square. 25 square. Yes. Yes. 20 times 20. What? Still not correct yet, Max. Again, again. So the final answer will be, oh, come on, Max. 25 times 25. 25 times 20 plus 5. 25 times 20 will be 500, right? Yes. Yes. Do it again. 2 times 2. What was it? 2 times 2. Of course, 4 lah. 400. 25. Of course, I can do it quick lah. What was it? Mm, this is 500, right? And then, so 25, 25 times 20 plus 25 times 5, right? So 25 times 20 is 500. 25 times 5 is 125. So the final result here, you do distributive property, right? You do distributive property. What was it? 225? Really? This is actually 25 times 25, right? But 25, I can write it as 20 plus 5, which is just the same, right? 25.5. 25 times 5. Yeah. So this is no, 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 no. Yeah, because it will be not the same, Bex. Yeah, because the result will be different. Yeah, because yeah, if you see it, yeah. Not that. Not like that, Bex. Not like that. Yeah, so it's supposed to be like this, yeah? So see the process, yeah? So this is 25. What we want to find is 25 times 25, right? So, yeah, so we do not want to change the value. Remember that. We just want to change the form, yeah? So it's changing the form with changing the value is a two different thing, okay? So what I want to do here, so 25, this is 25, right? But 25 itself, I can write it as 20 plus 5, which is basically 25, right? But using this, I can use distributive property. So 25 times 20, 25 times 5. So 25 times 20, 25 times 5. Of course, this will become much more easier, right? Because just this does the same as 20 times 2 times 10, right? Plus 125, yeah. 25 times 2, of course, this is an easy task, yeah. So 50 times 10, 500, and 125. So this will become 625. Okay, got it? Yes, it's supposed to be 625. Okay, maybe it will be a good thing. It will be better if you remember about the square of a number. Yeah, at least from 1 to 15. Yeah. Maybe 20. Yeah. 20. 20. Yeah, because you'll see it a lot. Maybe in your next study. Yeah. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared will be what, Bex? 4 squared? 16, 5 squared, 6 squared. Huh? 6 squared. 6 squared. 7 squared. Ah. 7. No. No, it's not 30s. No, not 56. Before 56. 49. Good. Okay, good. That's why you're doing mistakes earlier. Okay, okay. What about 8 squared? 8 squared, Bex. 8 squared. 8 squared? 8 times 8. Yeah, so 8 squared is 8 times 8. What is 8 times? What was it? Oh, wow. So, we do it like here squared, yeah. 8 times 8 is equal to 8 squared. So what is 8 squared then, Bex? No, 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 no. Still not correct. What was it? 8 squared. 8 squared. No, 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 no. I just mean the well, you know the concept of square, right? 8 squared, 8 to the power of 2. What was it? Hello, Bex. Can you? I'm so sorry. Can you hear my voice? Can you hear my Can you hear my voice? Okay, okay. Okay, good. Okay, 8 squared. 8 squared is 8 times 8. Yeah, 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 yeah. Square numbers. Yes. Yes. So 10 squared. 10. 100. 11 squared. 11 squared. Yes. This is where the game start to be interesting, more interesting. No, missing a number in the middle. You're missing the number in the middle. One in the beginning and one in the end. It's correct, but in the middle number, yeah, something's missing. Yeah. No, 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 no. Still missing another number in the middle. What about it, Max? So what is 11 squared? 110? No, 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 no. Still not correct. You can do it on a piece of paper. Okay. 100? Yes. Yes, that's correct. That's correct. Why you said 101 at the beginning? You said 101 in the beginning. You forgot about the another 20, right? Okay, 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 good. Okay. Let's move on to the questions, yeah. Let's move on to the questions. Okay, let's just end our discussion regarding about square number. Okay. So Q10, yeah, you can do it right. S is equal to n squared, where S represents. So this is the good practice, yeah, Bex, yeah. If you were to write the formula, you have to s- uh describe what variable of the formula represents. So S represent number of dots, N is the number of stage, yeah, or the iteration, yeah. And the computational thinking, if you ever heard about computational thinking, you heard about the word iterations, yeah, yeah. Iterations basically is the yeah. Have you ever heard about iterations, specs? Yes, yes. Yeah. Yeah, yeah. So, oh yeah, yeah, yeah. It can be like that. Yeah. So basically, thinking, yeah, thinking can be done by human and also computer, right? Or machine, basically a machine, right? Bex. So computational thinking is basically how can you elaborate your idea such that such that a machine or a human can understand what you're thinking of. Yeah, so that's basically the idea of computational thinking. Yeah, because well, human brain are such a delicate object. Yeah, such a delicate object. Yeah, that sometimes even the machines itself cannot really understand the human brain is what the human brain is. Yeah. So computational thinking is the way of try to think like how computer will think. Yeah. So basically, that's a computational thinking. That's the subject that right now I'm doing computational thinking actually. Yeah, because I have one subject in my in my university. The name itself is basically literally computational thinking. Have you ever heard about Python, Bex? Python language, coding, coding language, Python. Yeah, so basically Python. So my project is making an ATM machines using Python. Have you ever heard about Python? Oh, so what is Python, Bex? Mm, yeah, good. Yeah. Mm. Oh, yeah, yeah, that's true. That's true. Yeah. Good, good. Well, basically, Python, yeah. I wouldn't say Python is a machines, yeah. Python is a programming language. So Python is one of the language that you can choose to make a program, to make a something, make a game, or basically make anything that that we want. Yeah, yeah, yeah. Yeah, so Python is a is mm, what was it? Yes, yeah, yeah, yes. Yes, 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 yes. That's true. Yeah, because the Python itself, yeah. So Python itself is just translating a human thing into a computer into a language that a computer can understand. Yeah, but process of it is lies on our computer, lies on our hardware. Yeah, I would say the PC. Yeah, but what was it? Yeah. Oh well. Oh, artificial intelligence. So whoa, whoa. Okay, that's a much more higher levels of programming. Yeah. So basically, yeah. So in traditional programmings, yeah, yeah, we're talking about programming yeah, now. Okay, okay. So in traditional programmings, yeah. So in traditional programming, usually the developer, yeah, build a code to execute the programs, right? So we create a code and then we run it, and then the output, yeah, and then we get an output. Okay. But now artificial intelligence, in the other hands, yeah, we do not make the we do not make the what was it? Yeah, we do not make the program. We only yeah. So in artificial intelligence, what we do is we just give the rule to the computer. We just give the rule to the computer, and then we gave the computer a set of data. Yeah. After the data, yeah, raw data, not the program. So program is the instruction, right? The instruction of on how to do something, on how to do some things. That's a program. But the data, well, a data is random. It can be a random number, yeah, a set of number, yeah, based, for example, a data of the color in your car, the color of car in maybe in Jakarta or maybe in Shanghai, yeah. That's what we call a data. Yeah, so a bunch of informations. Okay, so in artificial intelligence, you gave the computer the rule and the data. You only gave them the rule. What was it? Uh, not really, because rule is only the, what was it? Yeah, I will call it a the guideline. The guideline. Yeah, yeah, yeah. So yeah. It's still, yeah. Yeah. So, but the program is more of an indirect programming, indirect in a way that we do not tell the data, we do not tell the computer how it should do something with the data. Yeah, no, but we only gave them the instructions. We only gave them a set of rules, and then after we gave those data, the computer will generate the program, the how step by step on how to process the data, and then we get the outputs. Okay, so the program will be differ according to the data, according to the data given to the computer. Okay, so that's what makes it different from artificial intelligence with traditional programming. In traditional programming, we create the step by step, the step by step program. In artificial intelligence, in the other hand, we somehow we only gave the of data to the computer, and a set of rules, and indirect rules, of course, yeah. And then the computer will create the program, the step by step. Yeah, that's what makes it difficult. Yeah, because sometimes we get a good model, we get a good artificial intelligence that can give us and a valid results. Yeah, but sometimes the model is not so good. Yeah, not so good because it doesn't train very well. So the more data that you had, it is more likely that the model or the artificial intelligence will be much better. Yeah, because yeah, well, they were trained more. Yeah, I can say that they were trained more. Yeah, because they are given more data. Okay, okay. Let's get back to, yeah. What was it? Okay, last time, Bex, before we move to our discussion again. Yes, 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 yeah. Yeah. For example, yeah, this is the last, yeah. For example, ChatGPT, yeah. So ChatGPT, in the development of ChatGPT, yeah, the developer doesn't program like, if a user search this, you output this. No. If the user input this, the program will output this. No. They are trained. They are the model, the ChatGPT is trained to, okay, you have this is a bunch of data. This is the data. You learn from it. Okay. And then you make the general pattern of the data. You make the general pattern of the data, and then the computer will recognize, oh, okay, from the data, if I have this, I output this. If I have this, I output this. I gave this to the user, and the process will continuous. Yeah, it means that the computer, I'm sorry, I have a call, wait a minute. Halo, halo, kenapa Jo?
Mas,
Oi,
Mas mau nanya-nanya tentang soal
Miss, bentar dulu Mas, lagi ngajar, maaf ya.
King aja.
ya. Ntar gua telepon lagi ya. Okay, let's continue ya. Okay, so that's what makes GPT, ChatGPT so what was it? Relatable, yeah, because they learn from the data. Okay, okay. Let's move on, yeah. Okay, so let's see for the 11 Q11. Test the general rule for S in term of N. Okay, so that's what we have done, yeah, earlier, yeah. So we have test the idea, we have test the general formula, and it the general formula holds, yeah, for n equal to 25. You can do it more with a much more bigger number, yeah. Okay, what about key 12? Verify your general rule for s in term of n. What was it? Oh, 100. Oh, the for the key for the for which one, Bex? For which problem? Verify your general rule for s in term of n. 144. Oh, no, no. Key 12. Key 12. Question 12. Question 12. Key 12. Key 12. Okay, key 12. Verify your general rule for s in terms of n. I think we already done it in the key 11, right? Test the general. Yeah, so it's very general. Yeah. Maybe it will be a kind of a difficult, yeah, for a sixth grader to really verify this formula. Oh, oh, okay. Mm, no. I think though they won't be teaching you this. Okay, it's too advanced for you. Okay, just okay. I think the key 11 and key 12 have the same spirit. Yeah, have the same spirit. So let's just assume that by have answering key 11, we also have answered key 12. Okay. Maybe if there's another changes, just tell it to me. Okay. So what about key 13? How many square will be in the 10th stage? Okay, key 13. So by key 13, so S, how many square will be in the, oh, square. Okay. Oh, oh, square. Okay. We're not. Oh, okay. Okay, so what is the general formula for finding the square then, Bex? So of the square, let's just use what is it? Z, yeah? Not Z, P lah, P. So let's use P to represent the number of stage. Oh, S is the number. We already use S, right? S is represent the number of dots, right, Bex? The number of dots. S represent the number of dots. In the other hand, in the key 13, the question asks for the squares. Question asks for the squares. So we already find the squares, right? So for the first iteration, you have 0 squared. In the second iteration, you have 1. In the third iteration, we have 2. This is 3 and 4. So by to find an arbitrary number of sides, we know that the square will be n minus 1, with p is the number of squared, right? And n is the of iterations, number of iterations. So if I have in the 10 iteration or the 10 pattern, 10 stage, what will be the square? How many the square will be, Max? If you have 10 in the 10 stage, how many squares will be? Oh, is there any other table in the manage book? Yes. The table that we did. Which one? This one, right? This one. Oh, okay. Let's just use what let's just use this, yeah? Let's just use this. Oh, why? Yeah. Just use this one. So if you have in the stage number n equal to 10, 9. Okay, good. So if you have n equal to 9, well, let me rewrite this. So if I have p 9 is equal to, I'm sorry, 10, yeah. And this is the 10 iteration. So 10 minus 1 equal to 9. Okay, good, yeah? Okay, another question, please. Okay, let's see another questions. Okay. Oh, there's already the answers. This is your answers or the teacher answers? Oh, okay. I'm sorry. The previous one is your answer or your teacher's answers in the below one. In the below of these questions, I see an answers in it. Is that your answers or the teacher? Oh, the teacher's one. Okay. Can I see the pattern? Okay. Let me see the pattern in the above. In above. Okay. I think you're very hungry. Mm-hmm. Okay, wait a minute. Can I see the pattern, Bex? Hello, Bex. Connections problem or something? Okay. Can you share your screen again? Oh no, I haven't screenshot the pattern. I only screenshot the questions. No, you can turn it on later. Yeah. Okay. Okay. Let me take a picture. Okay, I have to take a picture of it. Okay, let me move it to my screen now. So, okay, Windows. Yeah. I have take the. I have to take a picture with the questions for the questions. Okay. Okay. Have you seen my screen? Have you seen my screen now? Okay, good. Okay. Have you completed this assignment? This one? The question two? No, okay, okay, good. So, okay, it will be interesting, yeah? So, the sequence of diagrams shows pattern made from black beads and some white beads, yeah? Each diagram has two rows, more than the previous diagram. Diagram 1, diagram 2, diagram 3, and diagram 4. And this one, okay. Complete the table for diagram 5. So, this is, we have 4 diagram in here, right? So, for the first, you just what? Square numbers. Hello, Bex. Hello, Bex. Hello, 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 Bex. Can you hear me? Okay, good, good. I'm sorry. I think I lost my connection for a while, previously. Okay. What is it, Bex? What was it? Square number. Okay. How? How can you guess that this is a square number? Good, 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 good. Yes. Four squared. Yeah. Four squared. Yeah. Yeah. Okay. Okay. Good. Okay. So if I have, okay, for the number of bits, yeah. So for the A, yeah. So number of bits, for the number of bits, yeah. So if I have diagram number one, so I represent diagram number with the letter N. So N, for N equal to one, you have how many bits? Nine, yeah, which is the same as 3 squared. If I have N equal to 2, the bits will equal to 16, which is 4 squared, or 4 times 4. So N equal to 3, you have B equal to 25. 5 squared. N equal to 4 equal to B equal to 6, 36, which is 6 squared. And judging from the pattern here, if I have N equals to 5, B will equal to 7 squared, right? Which is 49. Okay, good, yeah? This is for the number of bits. What about the number of white beads? What about the number of white beads? Oh, by the way, okay, by the way. Oh, okay, let's just write it later, yeah. I want to discuss you about the general form, but okay, what was it? Oh, yeah, okay, good. Oh. I think that you can do that also, yeah, because based from my intuition, yeah, I think the percentage of the black beads and the white beads will be equal. Will be equal. Yeah, will be always equal in the, yeah, will be always equal in the diagram one, diagram two, diagram three. Yeah, but I think it will be kind of difficult. Yeah. Oh yeah, yeah. Oh, okay. Okay. If it's not the same, then we'll try another way. Okay. What will be the another way, Max? I think you don't have to really see the number, yeah, because yeah, if you see that from the pattern here, ah, okay, okay. Let's determine the white bits, yeah. This is the white bit first. In the white bits in the first diagram, how many white bits packs? Yes, 7. How many in the second diagrams? 10. How many in the third diagram? 13. Okay, so what is the pattern here, Bex? 3. Good. Plus 3. What about this? Good. Yeah, because it always add with 3, right? In the next pattern. 7 and then 3 plus 3, it will become 10. 10 plus 3 will become 13. 13 plus 3 will become 16. 16 plus 3 will become 19. So this is the this is the pattern, yeah. Always add 3 in the next pattern, right? In the next pattern. So in n equal to 5, the white bit will become how many bags? Yeah, in the fifth diagram, 19. Okay, we already answered it, yeah. Okay, what about the black beads? Hmm. Yes. Okay, okay. Let's identify it first, yeah, from the pattern, yeah. 2, 6, 12, 20, right? So from 2 to 6, you have to add how many packs? Yeah, so plus 4. What about the 6 to 12? You add with 6. What about 12 with 20? Good. So will become plus 8. So you will always add 2, right? Yay. So what about in the next term? You have to add, yeah. So in the difference, so the difference between 2 and 6 is equal to 4, right? So the difference is 4. The difference for 6 and 12, 6. 12 and 20, 8. So the difference itself will always going up again with 2. Will add again as the iteration go on. Yeah, so this will become plus 10. Yeah, so 20, 20 plus 10, 30. Good. So the for n equal to 5, the number of the black beads, yeah, black beads equal to 30. Okay, now for the for the for the hard part, yeah, for the B part, write down an expression for, yeah, for the first one, number of white beads. So how will you make the general formula for the white beads flex? You see the pattern, yeah? 7, 10, 13, 16, 19. Yes, okay. So if you have those numbers, how can you make that the pattern for the for if you have n for the n diagram, how many of the number of the white bits? 19 is for the fifth diagram only, right? The question asks for n diagram n, which the n itself can be a random number. It can be in the 7 diagram, in the 18 diagram, 20 diagram. Yeah, right? The formula. Yes. Yeah. So, what is the general formula for the yes, formula? An expression is a formula. Is a formula. This is a formula or equations. Okay, what is the formula, Bex? Yes, for the white beads. Yes. Okay. 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 Number of white beads. Okay, let's represent white beads. Okay, first let's represent white beads with what, Bex? Okay. Okay. What was it, Bex? So for example, white beads, let's represent it with W, yeah, equal to n n plus n plus 3. Okay. Okay, so n is the diagram n, right? So if I have diagram 1, okay, let's test it, yeah, verify. So if I have n equal to 1, the number of white bits will be equal to 4 dong, right? Is it true? It's supposed to be 7, bet. The data said that it's supposed to be 7. Ah, how would you improve the formula? Mm-mm. It's 3. Okay, this is kind of difficult, yeah. I think this is kind of difficult. This is kind of difficult. I would say that this is kind of difficult. Okay, yeah, this is kind of easy, right? Okay, okay. This is equation kind of hard, yeah, because you have to always you kind of have to find the expression so that if you have n diagram, you can get the number of white beads, right? Okay, let's I will do this question like this, okay? So In the beginning, okay, let's see the number first. Okay, so the number 7, 10, 13, 19, 16. 6, 13, 16, 19. So this is for the one diagram one. Let's call it the D1. This is D2. This is D3. This is D4. This is D5. So this number, this sequence of number will become our foundational in making the formula. Okay, to test the formula. Okay, so to represent the white bits at the N diagram, okay, so let's call it this WN. It means that a number of white bits in the N diagram will be equal to, okay, so let's start from the base case first. So in making an equation, you see the base case, the foundational case of the formula. The formula start from 7, right? 7 is the base case, the first diagram, right? So we start from there. Okay, we start from there. Okay, we have the first one is 7. We have the first one is 7. Okay, it's not done yet, yeah? It's not done yet. Okay. At the first case, we have 7. Okay, so how can we make it from 7? From 7, we can get the number of white bits in the second diagram, third diagram. Okay, so you see that in the second diagram, you add with plus 3, right? We add with plus 3. We add with plus 3. With the from the first diagram through to the third diagram, you have to add plus 6, right? Yes. From the first diagram to the fourth diagram, you have to add 9 plus 9, right? Do you see the pattern? From the first diagram to the fifth diagram, you have to add 12 here. Okay, so if I have n diagram, for the n diagram, the number of white bits will become 7 plus how many we will be adding it. Yeah. Okay, based on the n diagram, if we have n diagram, we have to add it with 3. Okay, times n minus 1. Understand it, Bex? If we have the second diagram, we have to add 3, right? With 3, kan? 2 minus 1 will become 1, and it will become 10. If we have a third diagram, 3 minus 1 is 2. We have to add plus 6. Okay, we have plus 6. 7 plus 6 is 15. Sorry, 16. Yeah, 16. Sorry, 13. What I was thinking. 13, okay? And this expression can be simplified to 7 plus, yeah, you can do distributive form, 3n minus 3, and this will become 3n minus plus 4. So this is the general formula to finding the white bits, okay? So if I have w equal to 1, this will become 7. Wow. If we have w equal to 2, it will become 6 plus 2, 14. 14. Ini benar gak sih? Wait a minute. I think I do some mistakes. Okay. Ya, oh ya, 10. Okay, 10. Benar-benar. 10. W3 will become 13. And so on, ya. So, get the idea, Bex? Yeah. So, this is the... So, you see the... How can we make the n? How can we relate the n with the number of bits? That's the tricky part. Okay, so what I do here is really how can we relate n with the white bits. Okay, the method I'm trying to apply is that, oh, the n can be the index. I would say the index to add from the beginning. How many I should add from the beginning, gitu. Yes, how many I should add from the beginning. We know that we always have to add it with 3. Yeah, But by how much? By how much 3 gitu. It could be 3, 6, 9, 11, yeah. Uh, like that. Okay? So, I want to how about the total number of bits? Okay, the second one. The second one, Bex. Okay, this is an exercise for you. The total number of bits. Total number of bits. Okay, the pattern will be 9, 16, 25, 36. Yes, good. Yes, good recognition. But how can we relate it with the if I have n equal to 1, I would get 9. How about n equal to 2, I get 16. N equal to 3, I get 25. How can I make a formula such that I could get this number? How can we make that x? Okay. Yes. Yes. 3 times 3. 3 squared. Yes. This is 3 squared, right? This is 4 squared. This is 5 squared. Okay. How can I get the total bits for arbitrary number of n? For random number of n? Yes. 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 49, right? Eh. Oh, yeah. Oh, yeah, yeah, yeah. This is 49, right? The total bits, right? Yeah, 7 squared is 49. 7 times 7 is 49, right? Max? Yeah, right. It is 49. Hmm. Yes, okay. How about if I have n squared? I have n, diagram n. How can I get, yeah, so how will be the pattern, Max? The, yes? Mm-hmm. Really? Is it? Okay, test it again. Not really, not really. It's not the answers. Okay, okay, how will be? Yes, good. But how can we but how can we find if I told you find the total bits in diagram 7, for example, maybe diagram 100, what will be the number of bits, Bex? Now, I want you to see this pattern, yeah? So diagram number 1, if I have diagram number 1, pattern will be the square the we add 2 to the number of diagram and then we squared it. See the pattern? So 1, we add 2 and then we squared it. We have 2, we add plus 2 and then we squared it. If I have 3, we see that this is 5 squared, this is 3 plus 2, and then we squared it. And then this pattern repeat again on and on, right? Yeah, Bex. S- So, have you seen this pattern earlier? Yeah, that's why, right? Yeah, that's why, right? So, what will be the general formula then? If I have n, if I ask you for diagram n, what will be the number of the total bits? The dot. Hmm? Yes, good, good, good. Yes, yes, yes. Bn. Yeah, which is we call this Bn, right? Good, good, Bex. Good. I'm proud of you. So this is n plus 2 squared, like this, right? So if I have b equal to 1, this is 1 plus 2 squared, this is 3 squared, this is 9. If I have b 10, so 10 plus 2 squared, this is 12 squared, which is 144. Okay? Like this. So I think there for one thing that I should tell you about finding a pattern is that there's no general rule in finding a pattern. So you can see the pattern from many perspectives. That's why finding a pattern like this kind of fun, yeah, because you can make your own pattern. If you see a pattern, some pattern you have to recognize which one is a pattern, which one is not. So a pattern is always repeatable. Okay, like I did earlier. Yeah, I see that if I have one, so maybe in finding a pattern, you have to hypothesize first. Hypothesize, hypothesize, right? You have to guess the pattern first. Okay, and then in your mind, just test it. Your wild idea of the formula, just test it, like I did earlier. If I have n equal to 1, I get that, oh, the total of bits is the number of diagram plus 2 and then squared it. Okay, let's test it for another case. Is it work or not? Okay, for n equal to 2, oh, okay, the formula that I make earlier in my mind, oh, it works. 2 and then plus 2 and then squared it. Oh, 16. Okay. And then 3. 3 plus 2, 5. 5 squared. Oh, okay. It works also. Oh, maybe that's the general formula. So you start by exploring wild idea in your mind, in your head. You test it. And if you're really convinced, oh, maybe that's the pattern. Okay, then road it then. If you already find the pattern. Okay. Like earlier, okay, like earlier we did that. Oh, maybe to find the square, okay, you start from hypothesize a thing, yeah, hypothesize or guess the formula. Okay, uh guessing itself can come from seeing the pattern in the that already been given in the questions. Okay, that's how you guess the formula. So we're not really making a wild guess. What we really done is that, oh, we're guessing from the pattern that was given by the questions. Yeah. So that's what we really do. So this is squared. We have 0 squared and then 1 squared, 2 squared, 3 squared. Oh, maybe the square will always s- add by 1 as the pattern goes on. Like that. X. I think that's how you should see how pattern recognizing is important. That's how you do computational thinking also. Yeah. So computational thinking is about one of the principle. The one thing that I also learned in computational thinking is that to find a problem, to understand a problem is to understand the pattern behind it. Yeah, because sometimes there is always a repeatable pattern behind a problem, and that's what we always seen in computational thinking. I think if you really like about finding a pattern, if you really want to explore about finding a pattern, just look up. There's an Indonesian computational thinking challenge problems that you can do. The website called Bebras. Have you heard about Bebras, Bex? Bebras. 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 Have you heard about Bebras? Ever heard of it? Have you heard about Bebras? Bebras. Oh no. Okay. This is let me share screen it with you. Okay. Bebras is a website. Is a website of a questions consisting of questions regarding computational thinking. Okay. And the kind of question of pattern recognizing will be a bunch of it in this website. Okay. If you really want to look up these similar questions, I think it will be interesting for you to uh, really do about it. Yeah. So this is yeah. So there's a lot of questions here. Astaghfirullah. Petir, I'm sorry. There's a flash in my dormitory all of a sudden. Kind of shocked with it. Bebras soal. Oke, let's soal SD. Bahasan soal. Oke, soal SD 2019. No, no, no. You don't have to buy it. This is free. Yeah, because it is provided from the government. Yeah, provided by the government. Yeah, but because of my poor connection, I could not access it for you. What was it? Yeah, well, it's kind of a huge book, I suppose. Yeah, I think it consists of because it consists of hundreds of questions, if I'm not mistaken. Yeah, yeah, yeah. So it's kind of wide. Yeah, kind of a lot. Wait a minute. Okay, okay. Ugh. Wait a minute. Okay, okay. It almost done. It almost done. Okay, okay. Good, good. Yes, almost done. Please, come on. Come on, please. Okay, okay, good. Nah, akhirnya. It's only 47. 47 questions. I think my internet. Problem is my internet. So okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What was it? Yeah, well, it's suitable with the elementary schools, right? This is for elementary schools questions like this. If you interested with it, yeah. So this is the questions. Yeah, this is interesting. Like this, if you want to see it, I think I'm gonna give you the PDF for this if you want to look it up. This is very good. This is very good. Let me save it for you. I'm gonna send it. Okay. Okay, Bex. I think what was it? Yes, a beaver. Yes. Yes. The plant, the water, the sand, bushes. Yeah. Yes. Yes. Hmm? 1,200? Really? Yeah. Okay. Let's see the. Okay, 1,200. We okay. Let's see. This is the route. Yeah, this is the route. Yeah, of course, yeah. Well, this is why computational thinking is unique, yeah, because you can use different paths, but the answers will, if you do it correct, the answers will be just the same, yeah. So there's a lot of way to roam, yeah. There's many ways to roam. Okay, I think I'll give you the PDF of these questions. I think this will be an interesting questions. Maybe if you want to a much more higher problem, you can do the high schoolers versions of these problems. But I think I won't give you that. Just I'll be just giving you this. Okay, Bex. Before we end our lesson today, is there anything that you want to add? Okay, good. Okay, as always, I'm gonna send the PDF, the Bebras PDF, and also the note for our today session. Okay, see you, Bex. Bye bye. Okay, okay. Okay, Bex. Okay, bye bye. Bye bye, Bex. Bye bye. Thank you too. Bye bye.